Okay, question 15. It is given that fx equals negative 2x squared plus 10, considering the following three curves: y equals fx, y equals f of x plus 1, and the curve y equals f of x plus 1 reflected in the line y equals to 6. The trapezium rule is used to estimate the area under each of these curves between x equals 0 and x equals to 1, and state whether the trapezium rule gives over or under estimates. Okay, so what determines if something gives an over or under estimate with trapezium rules? You know, if it's concave or convex, right? If it's convex, then it gives an over estimate, right? If it's concave, then it gives an under estimate, yeah? So, I mean, let me just use a picture to convince you. If the thing is convex, so something like this, yeah, if you execute the trapezium rule, then, I mean, it's clear that it's above, right? You know, that's a very bad picture, but you get the idea. Maybe I'm just going to use one trapezium. Like this, you see. All right. The straight line is over the curve, right? The straight line is over the curve. But then if it's concave, then you get something like this, right? The curve goes this way. And again, I'm going to illustrate with one trapezium. You see the straight line here is under the curve, right? So this is convex, and this is concave. Yeah, so convex will be overestimate, concave will be underestimate. Yeah? So let's see what we get. So y equals fx. So fx is a negative quadratic, yeah, and you know negative quadratics are always concave. Yeah, if you don't believe that, you can differentiate. Yeah? So how do we check if something's concave? You differentiate 2 times. Right? So differentiate once, that gives me negative 4x. Differentiate another time, equals negative 4, right? So you see why negative quadratics always are concave. Yeah, always. Okay, so negative quadratics are concave everywhere. Yeah, concave everywhere. No matter what value of x you sub in, the answer is negative 4, right? So it's concave everywhere. So this is an underestimate, right? Okay, how about the second guy? Y equals f of x plus 1. So you basically shifted the graph to the left by 1, right? But as I said, it's concave anywhere, right? The negative quadratic is always concave. So that's why it's also an underestimate, right? Okay, now the third curve though, the curve y equals f x plus 1 reflected in the line y equals to 6. So if you reflect it in the line y equals to 6, then, okay, no matter where you reflect it, doesn't matter where you reflect, like y equals 5, 4, 3, or 6, or 7, doesn't matter, right? The negative quadratic becomes a positive quadratic, and that's very important. The negative quadratic becomes a positive quadratic. So if it's a positive quadratic, then it becomes convex, right? Because the f double prime of x becomes a positive number, right? So if it's convex, then it's an overestimate, yeah? So the final answer will be under, over, yeah? Under, over, then you get B as the answer.